And we are live. Welcome, everybody. Thanks for joining tonight. We'll give this a few minutes to allow people to join before we get started. I can introduce myself. I'm Christoph. I'm your host tonight, and I'm here with Kaspar. Hey, Kaspar.
Hey, Christoph. Good to be here.
Thanks for being here, and thanks for sharing your thoughts on developer self-service on Kubernetes. Really exciting topic. So if you joined and I see people joining, then feel free to say hi in the chat. If you do so, make sure that you select all attendees before sharing your hi, because otherwise only Kaspar and I can see it, which is also nice, but I think you can do better. Maybe include from where you're joining if you want, so that we get a feeling of where people are listening from. Also, if you have questions during the presentation or discussion, then feel free to drop them in the chat. There also is a Q&A window that is available, so you can also use that for questions. I'll monitor that, and then I weave them in and make sure Kaspar is answering them either during the presentation or in the Q&A in the end. All right, 3 minutes in, let's maybe a few housekeeping rules. So this meeting is being recorded, and we will share the recording with you tomorrow in an email together with some useful links. And if you have questions, as I said, feel free to drop them either in the chat or in the Q&A section, and I'll make sure that we answer them in the course of this meetup. So welcome again. Let's get started. Welcome again from my side. I'm Christoph. I'm your host and moderator tonight. I'm really happy to see so many people. And I'm here with Kaspar, and Kaspar is going to talk about self-service on Kubernetes. So I assume a bit about how to deal with the complexity that Kubernetes can introduce into your overall setup. So Kaspar, welcome. Why don't you introduce yourself?
Yeah, now that find the unmute button. Thank you so much for having me. Yeah, I'm Kaspar. I'm the one of the co-founders at Humanitech, but I'm focused on self-service setups for pretty much the last decade, and that is something that really excites me, and I'm happy to share that tonight. Just a little disclaimer. There might be the need of switching to a different internet connection. Like there's just like, it's a worst case scenario, but from my experience, worst case scenarios, it's like with site reliability engineering, they always happen. And so, all
right.
In that case, bear with me, it will take 1 or 2 minutes. But I want to talk about developer self-service, in particular on Kubernetes. And that is a very exciting topic. Again, we're here from all over the world. I'm sure you have a lot of opinions, views, ideas, questions. Feel free to drop them in between. I'll try to cover them, or otherwise we'll cover them after the QA. All right, I want to make sure that I give you as much content as possible and as packed as possible, so you really take something away. And so what we're going to cover today, and like we're going to start a little lightweight. What is developer self-service? Why does it matter? And then I want to deep dive, dissecting the different elements of how to handle Kubernetes and how to enable self-service on those different elements. And I want to give you a framework of how to think about these things. I will develop that framework based on the total allocation of time that a developer has touch points with Kubernetes throughout the working day. Because I think that is a hands-on model in trying to understand these different components. We'll look at what are the blocking dependencies, how can you overcome them with self-service, and then I'll explain a new category of tools, internal developer platforms. We'll not touch base on any specific product, but I'll give you a hint how to look at this, what are the open source components to maybe deal with. Yeah, I think we'll have a fun evening, and let's get started and dive right in. This is a little aggressive aggressively here, but I think it's great to give your management the next time they don't want to invest in people or invest in tools. If you are slow, you die. And that is a quote that a friend of mine said, Jason Warner. He's the CTO at GitHub, and he is a pioneer if it comes to self-service, like a veteran of the early days of Kubernetes. GitHub was one of the first organizations to adopt that right from the start, which, like, if you recall, Kubernetes wasn't that great then. There were quite a few things that went wrong. But what they really nailed very early is that it's all about speed. Like, the faster you can develop, the faster you can deploy, the more you can innovate. And there can be found a direct, you can find a direct combination between developer velocity or development velocity and revenue growth. Our friends at McKinsey will link that study. The top quartile of these of highest performing development teams grow 5 times faster. So show this to your greedy management. All right, and let's take a step back and understand why teams don't ship fast, because it has a hell of a lot to do with self-service, right? And then I'll weave in Kubernetes in just a second. I personally identify 4 key reasons why teams don't ship fast. Number 1 is dependencies on colleagues. So every time you rely on someone else to do something, introduces a huge amount of lag and slack and toil. You have to ask a colleague for logs. You have to ask a colleague because you need a new environment. You have to ask a colleague for this. You have to, you vaguely know how to operate that, but you don't really know how to operate. And you just want to make sure. And then 5 minutes are gone, 10 minutes are gone, and those 5 to 10 minutes accumulate throughout the working year, and they are extremely inefficient. So the second thing is maintenance overhead. That for me has a lot to do with scripting, with configurations, for instance, configuration as code. And my dear friend Aaron, who ran the platform over at Salesforce, used to say, if you have 100 different microservices, we usually have 100 different, completely different YAML files in 100 different versions for 100 different environments. And the maintenance overhead that you're creating is just insane, right? The third thing is ineffective and broken workflows. The modern developer operates up to 11 different tools in the glorious cloud native world to bring stuff to production. And that is in itself, the number in itself is enough to understand why this workflow is broken. And so all of these things compound to cognitive load. And by cognitive load, I mean a developer wants to be focused on, like, wants to be the best in TypeScript, wants to be the best here, best there. And what they're actually ending up doing is understanding Helm charts, debugging this, trying to understand what environment variable is now, like, why is this workload now connecting to the RP token of Stripe that is used for testing. So all of these different things, and that is extremely unproductive. Now, the key to fix that is developer self-service. I deeply believe that developer self-service is really the brave new world because it eliminates dependencies, it lowers maintenance, it streamlines workflows, and it reduces cognitive load. Saying developer self-service is an awfully abstract thing to do, and I'm aware of that. And we are going to deep dive. And you might also ask the question, don't we have that already? I mean, we've proclaimed you build it, you run it years ago, right? So why is this strange German guy coming around the corner and everyone is talking about developer self-service? And I'm going to go there, get there, what I actually mean by that. What's interesting is the effect of developer self-service. And we've seen that in studies over studies, that the effect on KPIs like deployment frequency, like lower lead time, faster recovery from incidents, lower change failure rate is insane. There's actually the new Puppet report out. It's the Puppet State of DevOps, and you should Google it and have a look. And it's talking specifically about self-service setups and how high-performing teams have them, and like how insane the KPIs change. This year is very interesting. Last year is super interesting. I'm actually going to have a debate here with the CTO of Puppet around just these things and the latest trends around DevOps in a couple of weeks. Maybe Christopher, we can link this.
Yeah, we'll definitely share this and also the link to the report. I think it's useful. Absolutely.
Yeah. So and Nigel is super versed. It's really interesting. But kind of bottom line is that self-service matters. Self-service leads to a significant increase in all of these KPIs or decrease, depending on the direction. All right, now let's get away from this high level and deep dive a little bit more. And I thought it's interesting if we're staying in the Kubernetes world to look at all the things that you can struggle with, right? And then force rank this and try to attach a percentage to all of these things. How much time does a developer actually allocate? Or this is actually from a survey that we did, and it's not only developers, but it's really everyone. So how much time does everyone allocate to operating Kubernetes? And I think there are some interesting findings here. And what I mean is Kubernetes, but we don't think about this as one of the key mistakes that people do if they get into self-service, into Kubernetes, and then they set up everything, and then they say, aha, you spend a lot of time setting up clusters, which means we have to streamline the setup of clusters. It's not actually true, right? Because you spend a lot of time setting up clusters at the start of your Kubernetes journey, not so much down the road. And so those numbers are actually looking at the total lifetime of an application that is at least a year on Kubernetes. So if you do this and you throw everything into a basket and you crunch it, and then you say, what's the percentage allocation on the different things that you can potentially struggle with if you're operating Kubernetes? So let's look at this list. Super interesting findings. Basic thing, you can deploy a new image. What do I mean by that? What do we mean by that? You run some code change, you do a git push, a new image is built, and you want to bring that into the right namespace, and you want to make sure that, I don't know, everything is healthy. And yeah, so that's literally deploying a new version of your code. Second thing is debugging. You want to understand, it failed, production is slower than usual, test suites are throwing errors, and you want to look at the logs, and you might want to then like deep dive and see what's wrong with the cluster, and all these things have something to do with debugging and logging. Then you want to understand, and that is pretty high up the prioritization, what's running where. It sounds like a very trivial thing. It's actually not a very trivial thing if you are running lots of different environments, lots of different applications. What in the end, if you have a longer history with Kubernetes, is what you're ending up. You have a lot of different versions, you deploy, and even teams with the worst deployment frequency in the world pile up a lot of versions with a lot of different environments, and they may be like the worst case, and that's 16% of all cases that we record. Those teams are running multi-cloud, and it's making things even more complicated, and you don't know, okay, what's running where and what namespace, what cluster, what's the version, all of these things. So understanding what's running where is something that developers spend a lot of time with, if you look at it in the total perspective. The next thing is change in configuration. You don't do that often. So if you're very strict from a technical perspective, right, deploying a new image is a change in the configuration, but like we're abstracting. What I mean by change in configuration is you're adding an environment variable, you're removing an environment variable, you're changing container configs, and any of these things. Doesn't happen that often, but it does happen. Next thing is rollback. Something went wrong. You want to roll back to a previous version, or you want to understand what happened between versions. And there's a hotfix that needs to find its way to a production, and now staging is already ahead. You have to roll back, all of these things. Now, the next thing is spinning up a fresh environment. And that is something that is starting to trend. So getting away from static environments, staging, development, production, into I need a new environment, a QA environment to test something. But this can also involve, I need to have something materially new, like setting up a new service on a new environment, any of these things. Now then apply changes to the cluster. That means, and I don't mean changing the CPU allocation, I mean going in, looking at the networking, setting up a new cluster, any of these things doesn't happen as often as one might think. And then change resources. That isn't directly Kubernetes specific, but that could be like, I need a new instance of a database. I need to do some changes on the DNS setup, any of that. And then I've summarized automate stuff, completely original. What I mean is you are building some fancy Slack bot that signals, hey, the deployment is done, or you move a Jira ticket and then something else should happen. Any of these automations that generally make the workflow better. And then there are a couple of percentage points left, and I cluster them under other, and you can be creative and try to understand what is in that bucket. Now let's look at the percentage allocation. 70% of time, there's nothing else is happening, but a new image version needs to be swapped, right? And that is like a singular change, new image, to new namespace, and then it's done. In 10% of the cases, you want to debug something. Developer wants to understand, oh, this failed. Why is it failing? What's the problem where? 5% understand what's running where. It's like simply understanding the interconnections. 5% changing configurations. 2% rolling back. 2% spinning up fresh environments. Although, in my opinion, that would be significantly larger, that number, if it would be significantly easier. So we're a little bit caught. About so for I huge defender, if you want, it's extremely important to develop able to make these things and
Kaspar? I think we lost him. Yes, there is an issue with the audio. No, it's everyone. We all heard this robotic voice. I just wasn't sure whether it's my connection, but I think that's what Kaspar mentioned in the beginning, his not 100% stable internet connection. Let's just wait for him to join back. Meanwhile, if you have questions, feel free to put them in the chat or in the Q&A section so that we can dive a bit deeper into some topics. I read something about approaches for GitOps. Definitely a good question around that. But if you have others, feel free to post them. And let's just wait for Kaspar to join back. Let's see whether he has another connection. Yeah, I can see the first question in the Q&A section also. Feel free to use that. I think you can also upvote questions there. Seems to be a bigger issue on his side. There we go. Welcome back.
All right, here we are back again. 2 minutes, very sorry. The worst case, as usual, came true. Yeah, this is where we were. Again, very sorry, but you should be able to hear me, right?
Yeah, maybe you turn off your video. You still sound a bit robotic. Go ahead.
Better now? Is it better now?
Let's try. Yes.
You can hear me, right?
Yep.
Okay, so we went through this. Okay, and here we are. And let's assume that we have, assuming a fairly straightforward setup, like we're seeing that a lot, seeing around 350 different setups, good overview about what's used in reality. And so that's always something like managed Kubernetes with a GKE and EKS, any of that, OpenShift in that. Then you have something like Postgres, you as a database service, often manage your Prometheus. And let's say we want lead self-service without any abstractions. So we are basically like running a scenario here where we say, if the entire infrastructure, what would they actually need to know to operate the entire system themselves, right? And let's go through this. They would need to understand how to operate Argo. I mean, you can set it up for them, and then it works, and it will do most deployments. But especially if you debug, that is where things get like more interesting. You would need to have a good understanding, and we mean self-service, right? So there you go. Then they would need to be able to find, match, and understand logs, and they would need to know where the different logs are streamed, and you could then bring them together in a well set up Prometheus setup. But we're talking about a raw form, so they would probably also need to be able to get into the full console to find the correct log interpretation, and they would need to be able to set up, and everyone is able to navigate Git. One would think, I know a lot of teams where there are a lot of developers that aren't able to do that, contrary to what one would believe. And you understand, probably operate.
Yeah, Kaspar, it's still very hard to follow you.
and you would need to be, and then you would probably to least. Okay, sorry, let me try.
And he's gone again. Hey, Kaspar.
Is it better now?
Yeah, much better now.
Yeah, sorry about that. That was the position of the router. All right. Okay, so we need to operate Argo. You need to find, match, and understand logs. You need to navigate config as code setup in Git. You need to understand the Google console. You need to navigate the Google console. You need to be able to spin up other resources, which means you would need to understand how to initiate a Postgres and wire things up. You need to understand how your services fit together. You would need to be able to match the correct environment variables. You would need to deal with secrets management. And you would need to understand the Kubernetes cluster setup like in detail. Like,
do you want to share your screen again, Kaspar?
I'm not doing that. I'm really sorry. All right. You need to spin up other resources. You need to map how these things fit together. Deal with secrets management. All of these different components need to fall in place in order for a developer to really be able to self-serve end to end. And so I'm not saying that this isn't possible, right? I'm a big believer that everyone can learn everything. I'm a big believer that you can enable everyone. You can give them individual training. Like, all of that is possible. But what happens in reality, and that is just the reality that happens if we're looking into engineering teams, is that engineers are left alone. The management is not like ready to actually say, hey, you can allocate 3-4 weeks to just learning this and then learn this and then learn this. That you are thrown into these setups. I'm seeing that a lot if people migrate to Kubernetes in particular. People have very, very limited time to adopt. And then what that leads to is that you get back into a throw over the fence operations like we had in the 2005s, right? Where there were some poor people sitting in the basement and they had to deal, they had to take care of things, and one was left alone. And one of the reasons is that the modern world that we're operating today in reality is more complex than 15 years ago. And that sounds a little strange because you would say, there's progress, there was so much progress made, we have all these new tools, Kubernetes sounds cool, but the reality is that, and we are operating applications on a global scale that are used by thousands, hundreds of thousands, millions of users, that need to be redundant, that you need to run everywhere, we have so insane reliability needs to actually get the performance and reach all of the different things that is asked from us. And in reality, running a application, running a system today has much more complicated than 15 years ago, where you had a simple FTP request to get something up. So what you have to do is that you have to simplify, and you have to reduce the complexity. And you have to reduce the complexity in a way that you do not restrict creativity. That is the difficult balance of all of this. You have to give people the context to help them understand what's going on. I think they have to understand how the things are wired under the hood, but at the same time, in daily operations, you can't like overload them with all of these different things. And so what I believe is the golden path is to simplify through golden paths. And that's again a term that Jason Warnock coined at GitHub, and it means you give people abstractions that are golden paths and not golden cages. They simplify without restricting, and they offer a certain way and a certain set of defaults that works. Now, still sounds very abstract. Let's dive a little deeper. If you're looking into self-service capabilities for Kubernetes, there are 4 key elements that you have to abstract, if you want, to be able to operate the end-to-end thing of all of the operational aspects in day 2 operations of Kubernetes. You have to streamline configuration management. I deeply believe that the approach to configuration management that we have today, and I'll go through that in a second, is broken. You have to, sounds very simple, but I think it's very important, stream logs and all of the information, what breaks where, into a single interface. You have to visualize what's running where. People, if we recall, spend too much time trying to understand what's where. And then the 4th thing is you have to streamline infrastructure orchestration. And that means, how do you get new bits of infrastructure if that is required? Now, again, I force ranked them. I believe the most important thing is, if you want to focus on one thing, streamline config management, because it has so many repercussions on the other things. 2nd, stream logs. 3rd, visualize what's running where. And the 4th, streamline infrastructure orchestration. And you then want to standardize this against a self-service API or CLI, and you can do that by adding functionality bit by bit. Okay, still very vague, still very abstract. Let's deep dive. This is what everyone teaches us as application configuration management. So that, just throwing in a couple of names, the first level, if you're adopting Kubernetes, usually you're doing direct changes through kubectl. That is a nice little exercise, but not really scalable if you want to bring things into production. Why? Because you can't version this. It's difficult to roll back, and it's hard to handle if you're running this as a fleet, and if you want to deploy effectively. Then usually the next step is you go into configuration as code. You manage Helm charts, you teach everyone Helm, you save them to the repository. At that point, you look at GitOps and say, GitOps could be cool, and you look at Argo CD, and you build your first setup. And Helm, again, has a lot of different limitations. First and foremost, everything is stored in Git. Git is great for a lot of things. Git isn't super great to manage the configurations and different versions of configurations. It's still really hard to understand what's running where, and it's very, very hard to scale. And you are left with static environment setups. And now then you say, my Helm charts are so hard to read. Let's make this even more simple. And then you get into customize, and you say, can I build template certain things? Can I restrict the amount of things? And the reality is that in these approaches, there is still a lot of involvement in operations. If you look at a survey that we just did with, I think, 450 teams using Kubernetes, in 80% of cases, operations is involved in almost every change of a Helm chart. And developers don't do that themselves. And all of a sudden, you're back in the old world, where for every little change, there is a conversation, and those transactional conversations are a disaster if it comes to team productivity. So what's a better approach? A better approach is an approach coined by GitHub primarily, but that is used by a lot of teams now, by Salesforce, by Google in a lot of cases. And that approach is to say, if we have 100 different microservices, do the YAML files need to be materially different? And the answer of these teams is no, not actually not. YAML is a structured format, but YAML also gives you 1,000 different ways to express something. And that makes YAML, if it's human created, if you want, very, very hard to read, very, very hard to version. And the approach that these teams are using in self-service setups is that a central team, like an ops team, like a platform team, like DevOps, whatever, or senior developers, set so-called baseline YAML files. Some call them baseline Helm charts, depending on how you actually set them up. And those YAML files contain certain default things, like you're using Datadog for APM, it contains Datadog default information and environment variables. You need a sidecar with HashiCorp Vault. Okay, put it in. You want the CPU minimum allocation to be at 0.025 all the time, whatever. Once the baseline YAML is defined, you check that in with a platform API. So that's just a central API. And developers aren't actually applying changes to the YAML file directly, but you're surfacing the information. This is the basic information of the YAML file, and then the developers can apply changes. You can hear me, right? Yeah, okay. So then the developers apply changes to these different YAML files through the API, through a CLI or user interface, like adding an environment variable, changing the CPU default CPU allocation, changing the liveness probe, whatever. They can potentially change everything. If they don't change anything, then the defaults will be used. Now at deployment time, the system will, the self-service system will take those changes, diffs if you want, apply them to the YAML file, and then say, now this is a deployment going to a certain environment. Those are the infrastructure dependencies that I need to wire up, and then we'll create a set. And this is a machine created YAML file now that follows a very specific format. It's then again synced to Git so that you have a reference in a repository, and then it's executed automatically against the Kubernetes API. So this approach, which is a classical example of self-service setups on Kubernetes, makes it much, much easier to maintain different versions, because you can reverse the diffs, you can understand what happened between, you can do diffs and diffs, you can roll back much more fluently. And what you then do is, because you have a complete set of manifests for every single deployment, and it also enables you and solves all of the rollback problematic. All right. Now, I'm going to talk about the overarching setup, but streaming logs and service catalog functionality is probably something you can imagine. The last point I want to look at briefly is the orchestration of infrastructure, because that's the next thing that many people that are on Kubernetes already, operate Kubernetes, or are making their way into Kubernetes neglect. It's not only Kubernetes, right? There's also all of the different things that unfortunately cannot run in the cluster. Like, yes, you can run the database in cluster, but in reality, that is probably not super clever and not super effective. And so you end up with connecting to a managed Postgres, whatever. And so what we're seeing there, and that has it's not directly Kubernetes, but it has a vast impact, is that teams let developers do changes directly manual in GCP or in the Cloud Console. That means, okay, you have to understand the entire Cloud Console. Let's say that works. It still means that people can change everything all the time. At some point, you then get your first DevSecOps colleague, and the DevSecOps colleagues say, like, guys, we can't continue with that practice. Now, what you'll do is that you'll start using infrastructure as code, and you'll run into very similar problems, because you have permissions issues. People need to understand how Terraform works, or Pulumi, or whatever setup you're using. And an approach that we're seeing more and more, and we had a couple of other meetups here where we had a Spanish Adevinta, a company, talking how they built that. And it's interestingly enough, all of these self-service heavy companies use a very similar approach, and that's the approach of drivers. So how that works is that you don't let developers actually change
elements of the infrastructure directly. What you do is that you codify what happens at the request of a developer. So for instance, a developer, let's say you have a case, a developer A needs a fully provisioned environment on EKS, then this is codified by the ops team, and it's basically a written list of rules. If this request comes, please execute the following infrastructure as code files. Many teams use a concept called drivers in between that basically act as an execution mechanism and keep those things abstracted from each other. And then once the request from the developer comes, the platform API will say, aha, does this person have the RBAC? All right, now give them a new namespace in EKS, give them a fresh instance of a database, give them synthetic data, pull the registries from ACR, make sure DNS is provisioned with Route 53, whatever. And so this way, again, you keep the governance. Not everyone needs to know everything, although they have to understand what's running under the hood, and you have a self-service effective setup. Now, let's put these things together. This is what we're ending up, what we see people use in practice. You have a platform API. The platform API basically receives build notifications from the CI pipeline. The platform API deals with RBAC. It deals with the approach to config management that I just laid out, and it calls the right infrastructure at the right time. Those platform APIs are then usually developers usually intersect with their platform API directly or through a self-service UI or CLI, and you use the different setups, you manage that and center them through applications and services, building an environment management or service catalog functionality, and you stream in debugging and monitoring information into these things. And this setup that we're seeing here is what we call as a category internal developer platforms. All right, now, lots of information. There is one thing that I want to repeat, because I believe that many teams that are getting themselves into self-service are getting this wrong. Do not restrict developers. Very, very important. Those systems should be golden paths, not golden cages. Developers should always be able to script everything in low-level YAML or operate these things if that's okay from a compliance perspective. And because if you do it this way, if you're not doing it this way and you really restrict them, then they end up rejecting the system. If you do it right and you give them self-service capabilities, but you explain what's happening under the hood and you enable them to deviate if necessary, then we see in the data that 97% of teams are actually defaulting to these golden path self-service capabilities. All right, now before we get into QA, I want to give you a brief idea on how you could structure this if you want to get yourself into this. I already laid out that there is a clear logic that most teams follow. They first streamline application configuration management. That's usually where most of the problems come from. And they optimize debugging and logging. Then they're looking at service catalog-like functionality, and they keep the infrastructure set up static under. And if you really want to have a very advanced setup, you then deal with a dynamic infrastructure orchestration setup at scale. I've seen teams get into this platform world really, really quickly. There are a lot of tools out there now that can help you do this easier. We ourselves are open sourcing more and more of these drivers, for instance, so everyone can build their platform, whatever other tools they're using. And I want to point you to, and we'll link that in the email too, a site called internaldeveloperplatform.org, which summarizes all of that and gives you, it's a community curated list of stuff that you might also want to read or look into, or tools that you can use to build these types of platform. Yeah, lots of information. I hope it was useful. And I'd be happy to answer whatever question you have. I think we have 15 minutes left, or a couple of minutes left at least. Oh, it's I overrun. Sorry.
Kaspar, all good. Thanks. Yeah, we got some questions already, so maybe you can stop sharing your screen, then you use less of your bandwidth. Let's look into the Q&A, where we have it shows up for me. I'm sorry. The window is gone. Where we have the first question: does your definition of self-service mean you should build some fancy portal where developers can click around and order stuff?
I don't think you have to have a fancy portal where developers can click around and order stuff. I think that that is a taste question, and not every company can afford to spend money on fancy things. You can very well just start with a dry CLI to nail this baseline YAML-based app config management. That in itself is a game changer, and you can take it from there and develop this. These things can and should be developed bit by bit with incremental steps and feedback from users, and your level of abstraction is something that I can't, what you feel comfortable with is something that I can't answer for you. You and your developers, it heavily depends on whom you're working with, how experienced they are, what they feel comfortable with. And so these things have to be developed in a conversation.
Yeah, I think you're saying something important there. It's building an internal developer platform really requires listening to your developers, treat them as customers. I think is a good way to put that. Okay, then Marco Lehmann is asking, how is high availability with stateful workloads supported? Are there any operators available that handle these requirements automatically?
Yeah, so that's a very specific question. In my personal experience, that is I hope I get your question correct, but I'm not a big fan of having too much things run in a cluster, if you want. I don't think that this is what Kubernetes is actually meant for, and I don't think that there are great many tools out there that actually nail that consistently to a degree where you can then also roll this out to production. And if you can't roll this out to production, well, then you have to ask yourself how valuable that is and how representative your tests in the different environments actually are.
Yeah, cool. Not sure that answered your question fully, Marco, but if you have a follow-up question, happy to get into this. Then we had some questions around GitOps. So you briefly touched that topic of GitOps. What's your general opinion on that? Is that a good path to follow to start with? What are your thoughts around that?
I think there's nothing wrong specifically with GitOps. I wrote a longer article that I think offended many GitOps groupies, but I don't have a problem with GitOps at all. GitOps in itself is literally just the practice of syncing things continuously with a cluster. I have a problem with unstructured YAML files, and I believe that if you take back control of your zoo of YAML, right? How you then sync it to the cluster, I don't really care. Like Argo can do it reliably, anyone can do it reliably. It's just, after all, not that hard. Again, the problem is not after you deploy. The problem is, how do you actually get to the YAML file? And again, remind yourself of the Salesforce guy. If you have 100 different microservices, do you really require 100 different, materially different configurations, or can you structure this a little? Can you structure this a little more streamlined so that it's clear and it's clearly traceable how these YAML files were created? And then again, how you execute them, it really doesn't matter.
Okay, yeah, that's a good description. I think that if you're interested in to learn more about GitHub's approaches, I saw Stefan from Achievers in the meetup today earlier, and I'll have a meetup with him next week, how to nail developer experience in a GitHub setup. So if you're interested in how he nailed this at Achievers, then join that webinar. I'll also link that in the follow-up email. He has some great war stories on that. Okay, another question from Ankit. Does the below flow summarize what we are trying to achieve? Like Git, then a custom API, then the Kube API, and then the Kube API manipulates the infrastructure. Is that correct?
Yeah, sort of. So you have, yeah, exactly, Marcos. So you check in a baseline YAML in a repository, right? And then this baseline sits there. Now, the developer applies changes to, like, through the platform API. Let's say change container configuration CPU allocation to 0.3. The platform API will apply those diffs to a copy of the baseline YAML and create a fresh set of manifests, set that to the Git, and then execute this against the API server and the Kubernetes API server. And again, the synchronization can be done through the API directly or through a Argo CD runner. That doesn't matter. So Marco, spot on. And the baseline YAML is in the in Git already, and so then the copy is applied, a diff is applied to a copy of the baseline.
Cool, thanks. I think those were the questions. Thanks for asking, and also thanks to some of you for jumping in and answering things. I think that's always great to see if we get good answers from participants. All right, Kaspar, do you have some last words to wrap this up tonight?
Yeah, I'm very sorry for my connection issues. As you, I mean, I told you at the beginning.
You warned us before, so we can't complain too much.
I warned you, exactly. But yeah, this is a new category. I mean, I think we have to remind ourselves that Kubernetes is still a pretty new thing, right? I remember in 2018, we were choosing something for a project, like a managed service for a project, and EKS wasn't even rolled out in the European data centers. And that gives you a hint on how recent all of these changes are. The complexity increases with application lifetime, which is why more and more teams look at this. Don't be afraid of abstracting things, as long as you explain in detail what's happening under the hood, and always think about golden paths, never think about golden cages. I think that would be my pathetic final words.
I like this as last words. Thank you, Kaspar. Thanks everybody for joining. Sorry again for the sound problems. I think we fixed them. I hope we fixed them to a good degree in the second half. And have a great day or evening wherever you're listening from. Bye.